So what I've graphed for you are two parabolas, the red and the blue. These parabolas are just quadratic functions. We call the graph of a quadratic function a parabola. Let's talk about the red parabola. Notice how the red parabola has a nice U shape. The parabola is symmetric, that is, it can be a mirror image of itself. And the most important point on the red parabola, if you were to graph it, which one would it be? I would argue it is this point at the bottom. This point at the bottom, in this case it's the minimum, we call it the vertex. So a good starting point to graph would be to know what the vertex is. Now let's look at the blue graph. What is the vertex? The vertex is at 3, 2. Without the vertex, you're really just taking a guess at graphing. So it is really important to get the vertex correct. Now let's take a look here. The graph of a quadratic function is called a parabola. The most important point on a graph is called the vertex. The vertex is the turning point of a parabola. So just like I said before, it's sort of a critical place to start when graphing. Now you don't know what your vertex is here, so I'm just going to help you out. If y is equal to x squared, trust me on this, your vertex is 0, 0. So I'm just going to graph 0, 0. Now what might be some good x values that we can choose to graph? Well, we have one point on the parabola. Now for now, I'm going to lie to you and say we need 5 points. What x values would you choose? Well, for y is equal to x squared, I would encourage you to use these x values. If you notice, 0, 0 will be here. Now I've chosen 2 x values to the left of my vertex, 2 x values to the right. That should give us a nice shape of what's going on. So please press pause and you can figure out this table of values. So to figure out the table of values, we just simply plug in our graph. So for instance, when x is equal to -2, we get y is equal to -2 squared. So y is equal to 4. So from this fact, when x is equal to -2, y is equal to 4. Now when x is equal to -1, y, we simply plug in x into our function, and we get y is equal to 1. So when x is equal to -1, y is 1. Similarly, we could do that for when x is 1, y is 1. When x is 2, y is 4. This is how we construct a table of values. Now, if I take any pair on a table of values, I can get points on a graph. So this graph has points -2, 4, -1, 1, 0, 0, 1, 1, last but not least is 2, 4. So I'm just going to plot down the point, -2, 4, so we count the x first. 1, 2 units over, 4 units up, and there's my last point. And what we see is this is my parabola. It has this nice U shape, and the bottom of a parabola should be round. There we have it. I've graphed my first parabola. Congratulations, you have 2. Now, don't panic too much about the vertex yet. The vertex will get around to it. How do we know what the vertex is? I'll tell you. That's how, for now. If I take a look at the graph, y is equal to -2, x plus 2 squared, plus 8. Trust me on this when I say the vertex is going to be -2, comma, 8. Now I put -2 positive 8, but it's sort of implied. that it's 8. So negative 2, 8 is all the way over there. So what should I do when I graph? I'm going to ask you to graph 5 points. What x values should you choose? Well, I would encourage you, again, to take 2 points to the left, 2 points to the right of negative 2. Calculate those y values. So I'm going to say when x is equal to negative 4, my y value, I'm just going to plug in x is equal to negative 4. So I'm going to have to evaluate what's in the brackets first. And I'm going to square it. So this one is taking up a little bit more energy. So I get my y value is equal to 0. So when x is 4, my y value is 0. Now, if we do the same thing for negative 3, so I plug in x is equal to negative 3 to get my point. What I get is, I'm hoping anyways, remember that negative 1 squared simplifies to positive 1. I get my y value of 6. Now that's all good and fine. I'm going to put you out of your misery. You can do this by yourself. All we're doing is we're simply following the order of operations through. And I've been around the block a few times and I've seen a few parabolas. Keep in mind, this is my vertex, the most important point. And you're probably able to recognize that we follow some sort of symmetry when we're dealing with parabolas. Now take a look at the y values. 8, 6, 0. And then if you go the other way, it's going to be 8, 6, 0. There is some sort of pattern with the y values too that makes this really nice. And then when we graph this, if I plot my points, there is some symmetry not only with the numbers in the table of values, but there is some symmetry. Oh, I have to undo that one. That arm was crazy. There we are. There is some symmetry on the graph. So this is my parabola. I should put arrows to denote that it is continuous going down. And that's all there is to it. Most important point is the vertex.